Okay, now we're going to talk about, so we've been talking about data center virtualization, cloud computing, um, hyperconvergence, the software-defined data center. One of the key components of hyperconvergence um, is virtualized networking. We've sort of touched on that before with virtual network function virtualization. What we're doing here with software-defined networking is a little bit different. Software-defined networking, in this case, can apply to both to a virtualized network and to a physical one. I'd like to read you a couple of definitions. One out of our textbook, which says that software-defined network is a method of hyper-converging physical and virtual switches so they can be managed and configured from a central console. That's a good definition. I would also like to read a different definition of SDN from one of my Cisco books. This is the Connecting Networks book, sometimes colloquially will be referred to as CCNA 4 in the Cisco version 6 curriculum. And it defines software-defined networking as an architecture that decouples network control plane, from the network devices, forwarding plane. SDN brings automation and programmability into data center, campus, backbone, and wide area networks. That's also a good definition. What's happening here? Now, we've got every network device has actually three planes or fabrics. There's the data plane, where the traffic is actually flowing. Frames come in, are encapsulated, routed or switched, re-encapsulated, sent back out again on an exit interface. That's the data plane. The data is actually flowing through the network. The control plane, and now this might be a little bit confusing if you don't really think about how the system does what it does. If it all just looks like a big pile of stuff, wibbly wobbly, timey wimey stuff, it would all look like, hey, it's all the same thing. It's just a switch. The control plane is the intelligence within that network device that helps it to know what to do with those frames as they come in. How does it tag them? On the basis of tagging, of layer 2 tagging, VLAN with VLAN stuff, on the basis of layer 3 information. What decisions does it make? Everything from class of service to QoS to routing to switching to ACLs, all of it. All of that happens in the control plane. But how you tell that switch or router what it does, that's you interacting with the management plane. So if you get in on the console and you type in a bunch of configs and boom, you have an ACL, and you go into an interface and you tell the router that, hey, this ACL belongs on this interface, going in filtering traffic in this directionally, suddenly you have a functional packet filter on that router. So you've got you interact with the management plane, and the switch or router uses the control plane to manage the traffic that's going on in the data plane. So what happens with SDN is that we take that management plane and we disconnect it from the physical device. So you no longer have to go to physically or remotely access every network device to tell it what its configuration is. What you can instead do using a protocol like OpenFlow and the OpenStack protocol it's an open source protocol that allows you to communicate between your network devices, switches, routers, firewalls, ASAs, UTMs, the whole 9 yards. You use that central console on what is very definitely not an infrastructure device usually, and you decide what it should look like, what the network should do, and then you let the SDN code decide what the configs should be, and it pushes those out. And what you can do, particularly in a hyperconverged, truly virtualized network, You can change everything about the network on the fly. You change your routing, you change your addressing, you change your VLANs, your layer 3 topology, your layer 2 topology, your physical, your logical, all of it. You're in full control of the inside of your network. And VMware and Microsoft have been working with the network vendors like Cisco to build truly software-defined data centers. So the whole kit and caboodle has been virtualized. So you take SDN and the machine virtualization and the storage virtualization, you put it all together, and you have a whole bunch of devices in racks. And it doesn't, if you need to move up to, there will be some cost, some dislocation a little bit, but it's not as if like you have to go physically replace all of your routers and switches when you change, when you have to upgrade. Everything is virtualized. And it kind of looks like this. So you've got your orchestrator, your person, and there's your there's an abstraction layer. Your console, your person, deciding what, on a policy basis, what the network should look like. And then the open flow protocol reaches out to the controllers and reaches out to the individual devices and tells them, okay, this is what we're doing now. So that gives you an enormous amount of flexibility in terms of what you can do with your network. If you need to redesign the network, you need to split your network in half and completely resegment everything, you go for it. Now, this may also be tied in with cloud-based SDN systems like Cisco Meraki. Meraki, essentially, you don't go into the individual Meraki devices of the console. You tie them together, you interact with your console, and your console tells them what they should do. It's more like being a guy at the controls at the control center at Johnson Space Center, watching telling the astronauts what to do, than being the astronaut who's up in space flipping switches. So the next thing we're going to talk about is what virtual networking looks like inside vSphere. Then we're going to touch on Hyper-V's virtual networking, then virtualized network security, operation security, and then some other security stuff that we need to think about before we can really let the world loose on our networks, or let our networks loose on the world, however you want to say it. Thanks for watching, and I'll be right back.